words are from a particular root, and Ganita is from Gan, Sankhya, to count. And in Arthashastra of Kautilya it is said that Mito Ganitaha Sankhyatam Ganitam. Amarkos in Amarkos it is said that Sankhyatam Ganitam, which is measured and which is calculated, which is counted, that is Ganita. Again it is said that Arthashastra, having undergone the Chola ceremony, the students are learn, means after the Upanayana Sanskara, the student or the disciple learn the alphabets, lipi and arithmetics, means he has to learn, first of all he has to learn the alphabets and again the counting. Britta Chola Karma Liping Sankhyatam Cha Upajunjita after the Upanayana Sanskara. Upanayana Sanskara, it's a matter of point to say Upanayana does not restricted to Brahmans, because Upanayana Sanskara, Veda Patha and the rite in sacrifice, means Yajna Karma, has Trivarnika means Brahmana, Kshatriya, Vaishya and Sudra, and but gradually we have reduced it to Brahmins in this society. It has a large application for each and every parts of the society, directly or indirectly. Some interpretations though misleading sometimes. Again, mathematics is a language through which sciences are expressed compactly. This is the I think very briefly we can say what is mathematics. Again, the origin and development mathematics, if we see the Vedic age, as Indians do not believe the timing of the Vedas, because Veda is apaurushaya, because nobody has written, it is not a written document like other literature or other texts, and it is a transcendental or eternal source of knowledge. Therefore it is said that it is eternal and it is not man-made, or it is not authoritative. Apaurushaya, it is said that. But as we know, the foreign scholars and Western scholars have fixed dates for the Vedic literature. Someone's 4000 BC, someone 5000 BC or 6000 BC. In India, from Indian among the Indian scholars, Bal Gangadhar Tilak has fixed its time up to 4000 BC, from 6000 BC to 4500 BC. Anyway, that's another part of thing. First of all, the first and foremost contribution of Indians to the world is the discovery of zero. Without zero, think if there is no zero, then how one can calculate or go forward in mathematics or science or technology or anything else. So first of all, in Rigveda, the second mandala depicts the word zero. Bhuridavna avidang shuna mapehe. The word shuna is there, and it is fixed from mandala to second mandala to seventh mandala of Rigveda. The rishis are fixed, and the second mandala, rishi of second mandala is Grutsamada. There is the meaning of the word is also some another thing, but Grutsamada, we can say Grutsamada is the first inventor of the Suna, which means they are essenceless or nil. Again, in Taittiriya Sanghita is related to Krishna Yajurveda. Yajurveda is of two parts, Shukla Yajurveda and Krishna Yajurveda. And this Krishna Yajurveda, Taittiriya Sanghita is one Sanghita where from the smallest counting, 1 by 12, it spreads over to the biggest counting at the big numbers, 10 to the power 19, whereas in Greek civilization it was only for 10 to the power 4 or something at that time, as it is said in a book, Science in Sanskrit. Again we can say 10 to the power, but the words, the nomenclatures are very different. Therefore we Indians are unaware, we the modern scholars are unaware about it. The words are used for those numerics are Ardha for 1/2, Pada for 1/4, Sapha for 1/8, and Kushtha for 1/12. And the numbers, the powers of numbers: 10 to the power 2 Sata, 10 to the power 3 Sahasra, 10 to the power 4 Ayuta, 10 to the power 3 Nyuta, 10 to the power 6 Prayuta, 10 to the power 7 Arbuda, 10 to the power 8 Nirvuda, 10 to the power 9 Samudra, 10 to the power 10 Madhya, 10 to the power 11 Anta, 10 to the power 12 Parardha, 10 to the power 13 Ushasa, 10 to the power 14 Vyusti, 10 to the power 15 Deshyata, 10 to the power 16 Udyata, 10 to the power 17 Udita, 10 to the power 18 Savarga, and 10 to the power 19 it is Loka. It is in this way the words are used there in Taittiriya Sanghita, and the main it is a group of Vedic scholars. Taittiriya Sanghita, Taittiriya group, Taittiriya school of Taittiriya means the main rishi was Titiri, and his disciples and his group was named as Taittiriya. They have counted these numbers like this, and after that we find the sutra literature where the Sulla Sutras are meant for calculation or for measuring of the fire altars, for sacrifice, and for yajnic purposes. And after that again we should not forget the Jainas, the contribution of Jainas and Buddhas to the knowledge system, to the science and mathematics. The Jainas have also given importance to mathematics in their texts, religious texts, and their texts are known as Surya Pragyapti, Sthanaga Sutra, Bhagavati Sutra. There are 90 sutras in Bhagavati Sutra. Tattvartha Snigdha Tattvartha Dhigama Sutra of Umashwati, it's a lady, and Anuyoga Dwara Sutra, and Kshetra Samasha, Trilokashara, Uttaradhyayana Sutra. There are 20 sutras, and all these sutras discuss the mathematical calculations or mathematical expressions. And Buddhist literature regards arithmetic, that is Gana and Sankhyana, as the first and noblest among the arts. In ancient Buddhist literature, we find a mention of 3 classes of Ganita. First, Mudra, and this Mudra is also found in Vedic literature, as when one recites with swara or accents in different recensions of the Vedas, they use the hand and their palms to show the accents, that is whether Udatta or higher speech or lower speech or middle speech, they use the hands and their palms and their fingers, and so that is the origin. And in here also the Buddhist, and in Natya Shastra, in later stage in Natya Shastra, the mudras are developed, and mudra is the finger arithmetic, that is Ganana, then Ganana, that is mental arithmetic, and then after that Sankhyana, that is higher mathematics. And a book entitled anyone can go through it, a book entitled that is ancient Indian and ancient mathematics in ancient and medieval India by A.K. Bagh. It is published from Chokhamba Orientalia, Varanasi. And after that 18 Siddhantas, there are Siddhantas are found, and 18 Siddhantas were composed and named after their authors. And it's very unfortunate that most of the Siddhantas are lost, or very few are found in this way, and very few are available with us. But it is our responsibility to trace out the lost texts and the lost knowledge heritage. That should be the urge of modern research. And they are Surya Siddhanta, Paiti Mahasiddhanta, Vyasa Siddhanta, Vasishta Siddhanta, Atri Siddhanta, Parashara Siddhanta, Kashyapa Siddhanta, Narada Siddhanta, Garga Siddhanta, मरीचि सिद्धांत, मनु सिद्धांत, अंगिर सिद्धांत, लोमश सिद्धांत, पौलीश सिद्धांत, च्यवन सिद्धांत, यवन सिद्धांत, भृगु सिद्धांत and Sonaka Siddhanta. Most of these names are familiar to Vedic texts such as Vasishtha, Vishwamitra, Atri, Parashara, Garga and Angira, and then Sonaka. All are related to Vedic literature and Vedic text, and it's also a matter of research whether these rishis are the original rishis of the Vedas or they are renamed after this. Likewise, the Aryabhatta 1, Bhaskara 1, Bhaskara 2. Likewise, they are their predecessors or they are the original rishis. It's also a matter of research. Again, we directly now we come. Let us come for the Vedic text. The Vedic mathematicians. First, Bodhayana. He is the most oldest mathematician of Vedic literature, and his text is Bodhayana Sulva Sutra. And Bodhayana Sulva Sutra states the rule referred today in most of the world as the Pythagorean theorem, as you know, and we study. One reference of the Bodhayana Sulva Sutra is Dirgha Chaturashakshana Rajjuhu Parshvamani Tirjakmani Cha Yat Pruthak Bhute Kurutaha Tadubhayam Karoti, which means a rope stretched along the length of the diagonal produces an area which the vertical and horizontal sides make together. And his other contributions, other contributions is how to change a rectangular, how to change rectangular to square areas, and how to change a circle into square areas. All these are his contributions, and his Bodhayana Sulva Sutra is divided into 3 parts of chapter 1, chapter 2 and chapter 3. It is also available, and first of all it is published in the sacred text of the East series by Max Muller, it is with English translation from Oxford Publications and Oxford University Press, and it's the earliest Sulva Sutra. And circling the square and square root of 2 are his other 2 contributions. And next we will come to Manava, the next Vedic mathematician. As we know, they are geometricians. More appropriately we can say they are geometricians with calculations. Manava, his time is perhaps is about 750 BC to 690 BC. He is the mathematician in the Sulva Sutras is to enable accurate construction of altars needed for sacrifices. It is clear from the writing that Manava, as well as being a priest, must have been a skilled craftsman. Manava's Sulva Sutras, like all the Sulva Sutras, contained approximate constructions of circles from rectangulars and squares from circles, which can be thought of as giving approximate values of pi. There appear therefore different values of pi throughout the Sulva Sutras. Each and every Sulva Sutra discusses about the value of pi, and there is a very good paper, research paper is there. Some scholar has written about the value of pi in various Sulva Sutras, and very construction involving circles leads to a different such approximation. The paper of here, the paper is R.C. Gupta is concerned with an interpretation of verses. R.C. Gupta is also written that paper, and verses 11 and Manava's work, which pi, his value of pi is 25 by 8 equal to 3.125. This is the value of pi given by Manava. Then comes Apastamba. Apastamba Sulva Sutra has 6 sections, while Bodhayana has 3. And Apastamba has the significance of Apastamba Sulva Sutra is he has modified and elaborated the Bodhayana Sulva Sutra. he developed some sutras and modified some sutras. He has given the calculation of root square of 2, and he has depicted the general rule for calculation of root square of any number. It is roughly the Sula Sutras translate the rules of the crores, a series of 9 texts dated throughout the first millennia BC. Their contents are amalgamate of ritual construction, which basis was for religious purpose and spiritual purpose, but the technique they used to do it includes the mathematics and the geometries. The more prominent scholars are Bodhayana, Apastamba, Katyayana and Manava. All these 4 texts also with Hindi translation is published by Maharshi Sandipani, Rashtriya Veda Pratishthan, Ujjain, which is under the Ministry of HRD, Government of India. And this particular institution is organization is dedicated for the popularization or preservation of Vedic knowledge. And then we come to Katyayana. Katyayana is related to all these those 4 the mathematicians related to Krishna Yajurveda, because Bodhayana, Apastamba, Manava, all those are related to Krishna Yajurveda, and the Katyayana is related to Shukla Yajurveda. And the Pythagoras theorem of Bodhayana has been modified by Katyayana. And he is the Katyayana, not only a mathematician, he also is a grammarian and Vedic priest also of 2nd century BC. He has given the sutras how to make one square field to various square fields, and this is the picture. We can see how he has divided it, and for this he has written the sutras or aphorisms how we can change from one square to so many squares or multiple squares. This is his peculiarity. And after that we will come to the Aryabhatta, the middle age and the medieval Indian mathematician Aryabhatta. Aryabhatta one or Aryabhatta elder is possibly of Kushumapura of India, is a astronomer. Astronomy and physics and astronomy are not different from mathematics. Without mathematics they can't do anything. And astronomer and the earliest Indian mathematician whose work and history are available to modern scholars. It's very clear. He is known as Aryabhatta I or Aryabhatta elder. Distinguish him from the 10th century Indian mathematician with the same name. He flourished in Kusumaputra near Pataliputra, now the modern Patna. Then the capital city of Gupta dynasty, where he composed at least his 2 works, that is, one is Aryabhattiyam and another is Aryabhatta Siddhanta. And we found Aryabhattiyam in published form, but we do not found Aryabhatta Siddhanta so easily. Aryabhatta Siddhanta circulated mainly in the northwest of India and through the Sasanian dynasty of Iran. Had a profound influence on the development of Islamic astronomy, and Islamic astronomy is influenced by this Indian astronomy and by mostly by Aryabhatta. Its contents are preserved to some extent in the works of Baramira and Bhaskara I, Brahmagupta and others. It is one of the earliest astronomical works the modern India has. And Aryabhatta was particularly popular in South India. That means the Aryabhatta has the 2 contributions of Aryabhatta. One is popular in North-West India or North India, and another in South India. Aryabhatta was particularly popular in South India, where numerous mathematicians over the ensuing millennium wrote commentaries. And North India is famous in Sanskrit literature also. We find the sutras or the main text is written in North India, and the sutra or commentary literature is most of the way written in by the South Indians. And the work was written in verse couplets and deals with mathematics and astronomy. In Ganita, Aryabhatta names the first 10 decimal places and gives algorithms for obtaining square and cubic roots using the decimal number system. Then he treats geometric measurements employing 62,832 by 20,000, and that is 3.1416 per pi. And it's a very interesting thing that all the Sula Shutrakaraj and all the Indian mathematicians are have calculated pi in their own ways, and perhaps they vary slightly, but all have tried in their own ways and develops properties of a similar right angle triangles of intersecting circles. Mathematical series, quadratic equations, compound interest involving a quadratic equation, proportions or ratios, and the solution of various linear equations are among the arithmetic and algebraic topics included in the description of Aryabhattiyam. Then Aryabhattiyam ends with spherical astronomy in Gola, where Gol means that is circle, where he applied plane trigonometry to spherical geometry by projecting points and lines on the surface of a sphere onto appropriate planes. Topics include prediction of solar and lunar eclipses, that is the subject of astronomy, and ecliptic statement that the apparent westward motion of the stars is due to the spherical Earth's rotation about its axis or around its axis. Aryabhatta also correctly ascribed the luminosity of the moon and planets to which are reflected by the sunlight, and India government has named its first satellite as Aryabhatta, which was launched in 1975 in the honor of Aryabhatta 1, and one crater of moon is also named as Aryabhatta. And then comes another mathematician whose name is Brahmagupta, and Brahmagupta's time is 598 to 670. He has two texts. One is Brahma Sphota and Karana Khanda Khadyaka. In Brahma Sphota there are 24 chapters, and the arithmetic is his contribution to Indian mathematics. Intermediate quantity he has discussed about the intermediate quantity of numbers, and the algebra is also has invented by Brahmagupta. He has also discussed the geometry, and again he has some contributions for astronomy. And after that we come from Bhaskara 1. Bhaskara 1, I have not prepared all the slides because lack of time, and just I have my points with me. And Bhaskaracharya 1. Bhaskaracharya, there are two Bhaskaracharjas, and the Bhaskaracharya means we profoundly would know that Bhaskara 2, but Bhaskaracharya 1 has some contribution for Indian mathematics, and his time is 600 AD to 680 AD. And Bhaskaracharya has Mahabhaskariyam. His text is known as Mahabhaskariyam. He has modified the text of Aryabhatta 1, and he has another text is known as Asmaka Tantra, and Asmaka Tantra is known is written by this Bhaskara 1. And then so many are there. Then Mahavira, the Jainacharya, Mahaviracharya, 9th century AD. His time is 800 AD to 870 AD. Ganita Sara Sangraha is his text. All these texts are unknown to us, and are not well known to Indians, but all these texts are written by Indians, and it's our duty and it's our responsibility to know of what the theories and what the theorems are expressed by these mathematicians and these scholars, and it's our duty to reveal them and bring them to, in the front of this society. And another one is known as Sridhara. He is the Sridhara is a very famous mathematician of India. His time is 870 AD to 930 AD. And Sridhara is known for his Tri Shatika. He is known for his arithmetic and for his algebra. And Tri Shatika is his text. And these texts are also available, and it's our why it is not in the front line of our knowledge system, because the language is Sanskrit and the nomenclatures are used there are not well understood by all of us. Therefore it's not there in our curriculum. If it will be in English and Hindi translations, and the Aryabhatiyam, Surya Siddhanta, all these are translated into English and also in Hindi. So we can have a look upon these texts. And after that the Aryabhatta II, his time is 950 AD to 1030 AD. And he has two books. One is Mahasiddhanta and another book is known as Arya Siddhanta. And he has calculated the 22/7 is established by him as the value of pi. And Sripati, after that Sripati is a 11th century mathematician, and his time was 1019 AD to 1066 AD. And he has his contribution as a book named as Trikoti da Karana, and he has Ganita Tilaka, Dhruvamanasha, etc. are his books. These three books, Dhikoti Karana, Dhruvamanasha and Ganita Tilaka are his books. Then Acharya Hemachandra is a Jaina saint. Acharya Hemachandra, he is also a grammarian, and Hemachandra's contribution to Indian mathematics is Trisashti Salaka Purusha Rachita is his text. And Bhaskaracharya Siddhanta Shiromani is a very famous text. Most of the Sanskrit scholars who are from in the Jyotisha stream are well known with this Siddhanta Shiromani text. And tomorrow a lecture will be with from this Siddhanta Shiromani. And Bhaskaracharya too's Lilavati Sutra. Lilavati, actually there is a legend, not legend, maybe a true story. His daughter her daughter's name is Lilavati. She was devastated with the death of her husband, and she came back to his father, and his father enlightened her with the mathematical rules, mathematical expressions and mathematical descriptions. And after that Lilavati became illumined with the knowledge system, with his father's knowledge, and she invented some mathematical aphorisms or sutras which are known as Lilavati Sutra. And this Lilavati Sutra and so Siddhanta Shiromani both are the credit goes to Bhaskaracharya too. And he is not only a mathematician, he is also an astronomer. And then in modern time, Madhava is a 14th century mathematician, and he has written, he is a Malayali, and his book was Mahajayananda Prakara is his Sanskrit text, and he has also written a text in Malayalam that is known as Yukti Bhasha. And again the most eminent and prominent scholar of modern mathematician is Srinivas Ramanujan, whoever each and everyone is known with this name. We are proud about this Indian mathematician who is Srinivas Ramanujan. Though he is like a spark of knowledge, his lifespan was very small, 1887 to 1920. Srinivas Ramanujan, no books he has written in his very ill health. in a very poverty oriented life, but what he has given to the modern mathematics, no parallel or no comparison is possible. And Professor Hardy he, has tried to compile his notebooks, and now the Harvard University website has developed some archives to save those, to preserve, to explain those notebooks of Srinivas Ramanujan. And Srinivas Ramanujan's theory is known as Srinivas, the prime counting function is his contribution, and Srinivas Dhruvanka, and Srinivas Dhruvanka, or irrational number about is that is known the irrational number he has invented is named after his name, that is Srinivas Ramanujan Dhruvanka. Then Ramanujan number is also known, and more works, and Strand magazine also has published and more research papers about the Ramanujan mathematics. If we say it is Ramanujan mathematics, it's not wrong. And the one lady who is now is well known to all of us, this is Shakuntala Devi, and Shakuntala Devi is famous for her no lady is Lilavati, though Lilavati is there, and one Jaina saint is there. In modern Indian science, that is Shakuntala Devi, and she is alive now. Shakuntala Devi, 1939, she took birth in January 24, 1939, and she is in America, in Dells, in South Methodist University. She has delivered her first talk, and each and everyone became astonished with her brain. And she is, we can say, in calculation, she is like a computer. And with these mathematicians, my humble attempt and my humble submission is that we Indians must go through this, and our syllabus and our syllabus and our curriculum should include some selective portions of these Indian mathematicians and Indian mathematics, which we should not forget, and we collaborate. How we compare? We should compare, and our research should comprise, and the Indian knowledge system and our original knowledge system with modern mathematics. We can compare it. We can have a look upon it, and we hope that something new will come one day, and India will again step its foot in the map of the globe, as it was in the Vedic age, and it was in the Vedic time. Vishwaguru, India was regarded as a Vishwaguru, and because of this mathematics only, because of mathematics and Ayurveda and Yoga, and India is was known as Vishwaguru, and again we can revive, and we can have